Hello, good morning students. Now today, just after the atomic radius, we are just taking the next topic, that is screening effect or shielding effect and the effective nuclear charge. Okay, this is Z effective or effective nuclear charge. So for discussing this topic, let's take an example of an atom. That is example, let's take the example of, we can take the example of sodium. Okay, since the electronic configuration of sodium is 1s2, 2s2, 2p, 6, 3s, 1. Okay, this is the example of sodium. So I have mentioned over here, means drawn a diagram of an atom representing total 11 electrons. Here overall 11 electrons are present in first 2, then 8 electrons in second shell, in third shell outermost 1 electron, and here 11 protons are present. Okay. So what is actually shielding effect or screening effect? That I told you that if any of the electron is present in inside, and this one is the outermost electron, so there is a, means we can say this electron is since attracted by the nucleus, because all the electrons are attracted by the nucleus. But what happened, that since this electron is attracted by the nucleus, at the same time the inner core electrons, means these electrons are also applying a repulsion force on this atom. This repulsion force, which is applied by the electrons of electrons of inner core on the outermost electron, is called shielding effect. Okay, means the amount of repulsion which is applied over the outermost electron, that is net repulsion force applied by the electron of the in the outermost shell, that is called shielding effect or screening effect. Why they are means providing the shielding effect? Because these electrons actually means created a shield. Okay, they create a shield, or we can say a boundary, so that nucleus is not able to attract the outermost electron. So what is shielding or screening effect? It is when to overcome or to prevent the outermost electron from the attraction of nucleus, or we can say repulsion applied by inner core electrons to minimize the attraction between inner and outermost, means maximum, which is at most farthest place, that electron. Okay, this is called shielding effect. So in this, 11 protons are attracting 11 electrons, but the outermost, that is 3s1 electron, it is experiencing repulsion force by these electrons, and that's why it is shielding effect. That's why it is shielded, means it is prevented from attraction of the nucleus and it is experiencing the repulsion force, and that's why it is called the shielding effect. Okay students, the shielding effect actually depends on the atomic radius. As the atomic radius increases, the shielding effect or atomic size increases, the shielding effect is also increases. Now one more thing is there, that generally S subshell or S orbitals provides maximum shielding effect, then P, then D, and then F orbitals. F orbitals means due to very poor shielding effect, the lanthanoids in which F orbital is present, their atomic radius decrease at a very high speed, okay, on moving from left to right, because the electrons are added in the F orbital. Okay, that's why the lanthanoids, their size decreases at a very high speed. And so this is. Now we have to calculate Z effective. First of all, let's understand that what is Z effective. So what is actually Z effective is that we can say it is effective nuclear charge. We can say Z effective is also called the effective nuclear charge. Okay. So what is the effective nuclear charge? Let's discuss. So students, suppose let's take the same example, that is sodium. Let's consider that 11 protons are attracting the outermost electron. That means some attraction force is applied by the nucleus on the outermost electron. I'm just writing its name, that is 3s1 electron. Okay, on outermost electron, that is 3s1, this one. Similarly, at the same time, all the electrons are also applying the repulsion force, that is all these electrons are applying repulsion force on this outermost electron. So they are applying the repulsion force on this 3s1 electron. Okay, so actually the nucleus is attracting and the electrons are repelling it. That's why the overall attraction force, means we can say net attraction force. Net attraction force by nucleus on outermost electron, it is called Z effective और इफेक्टिव न्यूक्लियर चार्ज. सो बच्चों देखो क्या होता है कि बाहर, सबसे बाहर जो इलेक्ट्रॉन है, इस इलेक्ट्रॉन को न्यूक्लियस तो अट्रैक्ट करेगा, लेकिन बाहर के जो ये वाले इनर कोर इलेक्ट्रॉन्स है, जैसे 1s है 2s है, ये जो अंदर वाले इलेक्ट्रॉन्स है, दे आर रिपेलिंग इट. ठीक है, तो ये कितना रिपेल कर रहे हैं और इनके रिपल्शन के बावजूद भी न्यूक्लियस उसे कितना अट्रैक्ट कर रहा है. तो एक्चुअल अट्रैक्शन फोर्स में से जो रियल में ओरिजिनल में लगनी चाहिए, उस अट्रैक्शन फोर्स में से अगर हम रिपल्शन फोर्स को माइनस कर देंगे तो हमारे पास में नेट अट्रैक्शन फोर्स आ जाएगा न्यूक्लियस का, एंड दिस इज कॉल्ड द Z इफेक्टिव. तो हम लिख सकते हैं Z इफेक्टिव इक्वल्स टू अट्रैक्शन फोर्स ऑन 3s इलेक्ट्रॉन, that is electron on the outermost shell, and minus electron in minus repulsion force by the inner core electrons on the outermost shell electron. So this is called Z effective. Z effective का मतलब क्या होता है कि अंदर वाला इलेक्ट्रॉन है, इनके रिपल्शन को ओवरकम करते हुए न्यूक्लियस और आउटर मोस्ट शेल के इलेक्ट्रॉन में कितना फोर्स, कितना अट्रैक्शन फोर्स लग रहा है. ठीक है, अगर यहाँ पे शील्डिंग इफेक्ट ज्यादा होगा तो Z इफेक्टिव की वैल्यू कम हो जाएगी, अगर शील्डिंग इफेक्ट यहाँ पे कम होगा तो Z इफेक्टिव की वैल्यू ज्यादा हो जाएगी. ठीक है, नाउ लिसन स्टूडेंट्स, the value means there are certain factors on which the value of Z effective depends. For example, the Z effective depends on the principal quantum number. Okay, the Z effective depends on the principal quantum number. Principal quantum number means like n is equals to 1, n is equals to 2, n is equals to 3, and so on. So Z effective, you have to remember that value of Z effective depends on the principal quantum number. As the value of principal quantum number increases, like the number of shells increases, then the value of Z effective decreases. Okay, and you know that across a group from top to bottom, the value of n increases, that is the number of shell increases. That's why the effective nuclear charge decreases. Okay, because shielding effect is also increasing. Okay, second thing that you have to remember is Z effective. There is an order for the Z effective, that is we know that you have to remember it. Okay, that the effective nuclear charge means applied, the effective nuclear charge of s electrons is more, then P, then more, then D and then F. तो ये आपको ध्यान रखना है, ये मैंने स्क्रीनिंग इफेक्ट का ऑर्डर नहीं लिख रही, ये लिख रही हूँ मैं इफेक्टिव न्यूक्लियर चार्ज का ऑर्डर। जैसे मैं आपको एक एग्जांपल शो करना चाहूंगी, है ना। So students, here is an example, like I have written that Z effective is inversely proportional to the principal quantum number, as well as it also the s orbitals shows maximum Z effective, then P, D and F. Okay, because as soon as the principal quantum number will increase, then the value of orbitals will also increase, because the number of shall increase, screening effect will also increase. So here this is the order of the Z effective. Now there are different type of, we see that there are different type of orbitals, and we have to arrange them in the order of maximum Z effective. So since we know that first of all 1s, 2s, 3s, so the Z effective is inversely proportional to principal quantum number or number of period. So the group or the means this one represent the n, that is principal quantum number or number of period. So the value having the minimum value of n over represent the maximum Z effective. So 1s, it is representing the maximum Z effective. Afterwards there are, the second is 2, here we are having 2p only, so 2p is having maximum Z effective. Then 3s only it is, so 3s. Then this we have done, this we have done, this we have done. Then 4p and 4s. Now among 4p and 4s, because both are having the same quantum number, same principal quantum number, so in this we will see this one, that the 4s orbital is having more Z effective as compared to the 4p. Similarly among these, 5d is having more Z effective than 5f and 6s. So this will be the order of the effective nuclear charge for different type of subshells, different type of orbitals. Okay, so this is the Z effective. Now student, one more thing is there. These are so simple factors which affect the simple factors affecting effective nuclear charge. Now we have to, there are certain methods, or there is a means rule which is used to calculate the effective nuclear charge. Okay, so how can we calculate the effective, to calculate or to recognize the screening effect, that how much effective or net attraction force is there of nucleus over the outermost electron. To calculate that force, there is a rule, and this rule is called Slater's rule. This rule is called Slater's rule. Okay, with the help of this rule, we are able to calculate the effective nuclear charge. According to Slater's rule, the effective nuclear charge, it is equal to Z minus sigma. Okay, it is equal to Z minus sigma. And what is actually Z? Z effective is the actual or net nuclear charge, or the, we can say, net new attraction force of nucleus on the outermost electron. Okay, just after means even after overcoming with the shielding effect. Z is here, Z effect is the effective nuclear charge, or you can say actual, or you can say net nuclear charge, or we can say this charge actually represents the attraction force. Okay, Z is number of protons, which is equal to the atomic number also, and sigma is the screening constant. Screening constant which represents the amount of screening effect. So if we are just means the total among the total attraction force of nucleus, if we are just subtracting the amount of repulsion force by the inner core electron, then we will get the effective nuclear charge. So there are certain rules for calculating the effective nuclear charge for any atom. Okay, so we have to go through these rules. Now students, we are discussing about the rules. Since Z to calculate the Z effective, we are already having the value of Z or atomic number and the value of sigma we have to calculate. So there are certain rules which we are going to discuss. Now number one is that for any single electron containing species, means all those atoms or ions which are having only a single electron, their sigma will be 0. That means screening constant or screening effect will be, in these species screening effect will be 0. Let's have a look. For example, hydrogen is there. So in hydrogen, one proton is there and one electron is there. So nucleus is attracting the electron, but there is no other electron to repel this electron. That's why the screening effect is 0. So screening effect will be 0, so we can easily calculate the effective nuclear charge. The effective nuclear charge will be equal to Z minus sigma. For hydrogen atom, you know, Z is equals to, or means Z effective is equals to 1 and sigma is equals to 0, so it will be 1. Let's calculate for lithium plus 2. Okay, so lithium plus 2, Z effective will be 3 minus 0 is equals to 3. So you know that means in this way we can calculate the Z effective for single electron containing species. Now for bi-electronic species, means such type of species in which 2 electrons are present. Let's take a look, like we are taking the example of lithium Li plus 2 or Li plus, or we can take the example of helium. No problem. Suppose lithium is there, so lithium 3 protons are there and 2 electrons are there, because it is Li plus, so it has donated 1 electron. In this case, only we know that only single electron, means this electron is there and only a single electron is present to apply the screening effect. So in this case you have to remember that for bi-electronic species the value of sigma will be 0.3 simply, or you can write 0.35, no problem. So Z effective for lithium will be equals to 3 minus 0.3. So it will be equal to approx 2.7. Okay, so the value will be 2.7. So these are the two rules. Next one is now this latest rule for multi-electronic species. If the species are multi-electronic, that means the different number of electrons found are different. So you have to remember, but just try means I will explain this by taking an example. Okay, like let's take an example of simple zinc or potassium. So the electronic configuration in any of the, if you want to calculate Z effective for any species, then for multi-electronic species, first of all you have to write down the electronic configuration in increasing order of principal quantum number. So let's see that the electronic configuration of potassium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, sorry, 4s1. Okay, so over here if it is given, let's consider if it is scandium, then in that case it will be 4s1 3d, 4s2 3d1. So what we have to do, that first of all we have to write down the electronic configuration of elements in increasing order of their principal quantum number. So we will write it like this: 1s2, 2s2, 2p6, 3s2, 3p6, 3d1, 4s2. Okay, we have to write it like this way, that is in increasing order of the principal quantum number. So first thing we have done, that for multi-electronic species, we will write down the electronic configuration of any atom in increasing order of the principal quantum number. Okay, now what will we do? What we will do, we will just calculate the value of n. N is the outermost shell. Means we will, first of all, what will we do? We will actually means mark arrows or mark the line under S or S and P for the same shell. Like 1s, it is first period, so we will put the mark like this. Then second period has S and P, these are. For the third period, SPD, but I am asking for S and P. So we have to mark for S and P only. This is D and this is the fourth. Separately mark D and F orbital, no problem. Okay, this is called as N3. This is called N minus 1. This is called N minus 2 and this is N minus 3. So in this way we can represent them. Okay, now what will we do? We have to actually put the value of sigma. You have to remember the value of sigma for each and every shell. So for one electron, like for N, if S and P orbitals are present, as outermost orbitals are S and P in which electrons are present, like here S is there in which outer electron is present. So we will use these values of sigma. For N orbital we are using 0.35, for N minus 1 we are using 0.85, for N minus 2, N minus 3, N minus 4, 5 and so on we are using the value N. Okay, this is for one electron, so we will calculate the number of electron for N minus 2, N minus 1 for N, and then we will calculate the value of Z effective and first of all sigma total. If outermost electron means outermost shell or outermost orbit in which electrons are present in N, F or ND, then in that case we will use the value of sigma 0.35 for 1d orbital, and for the other we are using value 1. Okay, so better for us that we will do certain examples so that we come to know. So students, in the next video I will tell you, we will do the question related to Z effective. Okay.